So in this lecture, you're going to learn about yet another conversion factor. This one's called molar mass. I'm going to use periodic table version 1 to get all my values here. If you go with a different periodic table, you're going to get slightly different values, but it's not a big deal. As long as you're ballpark the same, everything will work out in the end. So in this first problem, we're asked to calculate the molar mass of potassium iodide. So there's one potassium and one iodide. We know those ones to be understood. So I'm going to start organizing it here. So I want to look up, on my periodic table, I want to look up the mass of potassium. So if I go ahead and do that, I get 39.098. And I want to do the same thing for the iodine. So there I get 126.9045. And we're just going to add those two values together. So I got 166.0025 when I did that. Let's work on a couple of different things. First off, sig figs. So we have 3 decimal points with our potassium and 4 decimal points with the iodine. So the best we could do is go to 3 decimal points. I'm going to look at the number right next to it. There's a 5, so I'm going to want to round up. So I'm looking at 166.003 as my value. Of course, you can give this units of AMU, atomic mass units. But for the problems that we're about to do during this week of material, the AMU is not super helpful. So the conversion factor comes in because we're going to start using a new set of units. We're going to say that this is grams per mole. And in the next lecture, I'm going to explain exactly what a mole is. But it represents a whole bunch of molecules or atoms. And you can see, like, it's a fraction, right? And so you can see how, maybe with thinking about density as a conversion factor and other things as a conversion factor, how this might become a conversion factor. So we can write there's 166.003 grams of potassium iodide in 1 mole of potassium iodide. So that's one way that we can rewrite this value, and it's going to be super useful. And then you're going to flip it. You might need to use it this way. You might need to say 1 mole of potassium iodide contains 166.003 grams of potassium iodide. So 2 conversion factors, and all the information is from the periodic table. Let's do the next one. So here we have iron 2 sulfate. It's got 1 iron, 1 sulfur. I'll put some 1s out front. And 4 oxygens. So it's going to look very similar to the previous one. I'm going to look up the molar mass of iron. So 55.84 grams. Maybe I'll leave out the units till the end. And sulfur is 32.07. And oxygen is 15.999. But I'm going to want to multiply that by 4. So in my calculator, and this is why I have parentheses here, I would type in 55.84 plus 32.07 plus, and then I would open up my parentheses, do 15.999 times 4, and then close the parentheses. I'm going to put all that in just one step in my calculator. Just makes life easier. And when I did that, I got a value of 151.906. And again, check sig figs, make sure that's all fixed. So 2 decimal places here, 2 decimal places here and 3 decimal places here. So it looks like we can only go to 2 decimal places. So I'm going to round this up because of the 6 to 151.91. And let's go through those conversion factors again. So this number has units of grams per mole. So we can say that there's 151.91 grams of iron sulfate in 1 mole of iron sulfate. Or we can flip our value or flip this relationship and say 1 mole of iron sulfate has 151.91 grams of iron sulfate. And both versions of this are going to come in super handy very shortly here. Number 3, we're asked to calculate the molar mass of calcium carbonate. So we have 1 calcium, 1 carbon, and 3 oxygens to account for. So using my periodic table, I got 40.08 for the calcium, 12.011 for the carbon, and the oxygen was 15.999, and I want to multiply that number by 3 since there's 3 oxygens in the formula. When I added it all up, I got 100.088, and this is going to have units of grams per mole. Totally would write my conversion factors using this value. However, if I just need a molar mass and this is going to be my final answer, I need to look at decimal places since I was adding. So if this was my final answer, I would say it's 100.09 grams per mole because the calcium only has 2 decimal places. On the next one, there's a couple more things going on here. One, we have parentheses. So when we have parentheses, we need to remember to distribute the number outside the parentheses to the elements inside the parentheses. The other thing is they switched up the wording a little bit and said calculate the formula mass. And so officially, formula mass has units of AMU, atomic mass units. However, the value is going to be the same. And so if we have a value in AMU, but we need a conversion factor, we could totally just change the AMU to grams per mole. Let's crunch the numbers here. So we have 1 barium and 2 oxygen and 2 hydrogen. So 137.33 for the barium, 15.999, multiply that by 2 for oxygen, and 1.0080 times 2 for the hydrogen. And when I put all of that into my calculator, I got 171.344, and that has units of AMU. If I need a final answer, I'm going to round it to 2 decimal places because of the barium. So I would do 171.34 AMU. All right, in problem number 5, they gave us a Lewis dot structure instead of a formula. And you might look at this and figure out that this is a drawing of carbonate, one of our polyatomic ions. However, even if you didn't reach that conclusion, you're still going to be able to do the next part. So you can count up what you see. You see 1 carbon and 3 oxygens. Another important thing to mention here is the mass of the atoms won't change just because of the charge. So ions have almost the same mass. As far as we're concerned, it's the same mass as the neutral species. And the reason why, you probably already know why, right? Because electrons are in that electron cloud and they don't really contribute to the mass. So even though this species has 2 extra electrons, it's not a big deal and it's not going to impact anything that we're going to write here. So we're going to grab the mass of carbon, 12.011, and we have 3 oxygens. So I'm going to do 15.999 times 3. Add that up and I get 60.008 grams per mole. Both values have 3 decimal places and my final value has 3 decimal places. Another Lewis dot structure to interpret. On this one we have 1 nitrogen, 1 fluorine, and 1 oxygen. So nitrogen is 14.007. Fluorine, this periodic table with the fluorine, that's a lot of sig figs. I don't understand, but 18.99840316, and the oxygen is 15.999. So when we add this all up, we get 49.00440316. And the nitrogen and the oxygen only have 3 decimal places. So I'm going to just report this answer to just 3 decimal places. So I'm going to say 49.004 grams per mole, because they asked for molecular mass, so I'll use grams per mole. So on number 7, we need to be super careful about our distribution here. So I'm going to distribute the 3 to the nitrogen and to the hydrogen. So that gives me 3 nitrogens to account for and 12 hydrogens. There's just 1 phosphorus in the ammonium phosphate and 4 oxygens. So I'm going to look up all those molar masses. Nitrogen is 14.007, so I'm going to multiply that by 3. Next we have hydrogen. I'm going to multiply that value by 12. Phosphorus is another one with a bunch of sig figs. 30.9737 62000, and then the oxygen is 15.999 times 4. I'm going to enter all this in my calculator with plus signs in between each line here. And when I did that, I got a value of 149.0867662, and it goes on because of all the sig figs. However, at the end of the day, I only have 3 decimal places, so I'm going to round this to 149.087, and this is going to have units of AMU because they asked for formula mass. But if I was doing a different type of problem, I could totally just change the AMU to grams per mole. They're interchangeable like that. Next one, this is probably the most frequently missed problem when we do this lecture packet together in class. Reason being, people get very excited and they write down calcium and they write down nitrate. But when you're given the name of a compound, you always have to make sure that you're doing the crisscross and making sure you're considering, what does this formula look like? So I'm going to do calcium 2 plus with NO3 minus and I'll put some parentheses there. And so when I crisscross this, I get CaNO3 2. So for my math here, I have 1 calcium, and I'm going to distribute that 2 to both the nitrogen and the oxygen. So I'm going to have 2 nitrogens and 6 oxygens. Grab all those values off of your periodic table. And then it's another problem where they specifically asked for formula mass. So I'm going to say that this has a mass of 164.088 AMU. If I needed to report a final answer, because of calcium, it just has 2 decimal places, I would have to say it has 164.09 AMU.